Okay, so let's look at solving radical equations. Like I said, I'm going to go fairly quickly. Let's just review real quickly. This is a square root function, correct? What does the positive 2 make the graph do? It's going to go to the left, 2. What's the negative 3 do? Down 3. X minus 1, what's that going to make my graph do? To the right. And up. What are my magic numbers? 1, 1, 1, because the square root of 1 is 1. What's my next magic number? Normally, if it was a quadratic, we would go 2, 4, because 2 squared is 4. But since we're doing the square roots, right, we would do the next root is 4, 2. Square root of 4 is 2. And then what? 9 and 3. Good. Let's do this review. Cube roots. Let's do the magic numbers for cube roots. The cube of 1 is 1. What's the next cube I can find? 8 and 2. What's this going to make the graph do? Left 1. What's this going to make the graph do? Left 5 and down 4. We're good on review? Awesome. Let's go ahead and just graph this real quick. So, on this one, I start at 0, 0, but instead I'm going to go left 5, 1, 2, 3, 4, 5, and down 1, 2, 3, 4. Magic numbers, 1, 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, 2. So that's what that would look like. All right, moving on. So this is what we're going to do today, solving radical equations. Remember, let's see, probably a couple chapters ago, we would split a function into, or split an equation into 2 and graph the 2 functions. You guys remember that? Vaguely? That's what we're going to do today. Okay, so I'm going to go ahead and let me duplicate this page. 1 duplicate, 2 duplicate. All right. Let me just get rid of that. And we're just going to look at this first one. All right, so what I'm going to do is I'm going to split this equation, right here, split this equation into 2 functions. A square root function, which is the square root of x plus 4, and a constant function, g of x equals 2. The left side is my square root function, the right side is my constant function. I'm going to see where they meet graphically. So I'm going to graph, this is my parent function, correct? 1, 1, 1, 2, 3, 4, 1, 2. Parent function, and it's going to shift to the left, 1, 2, 3, 4, just like the function says. And then my constant function is going to be at 2. Their intersection is right here. And that intersection is where x equals 0. If I were to plot this point is 0, 2, where x equals 0. All right, now I'm going to solve it algebraically. So I have x plus 4 equals 2. If I want to get rid of a square root, I do the inverse, which is square. So now I have x plus 4 equals 4. And x equals 0. Algebraically, graphically. What's the beauty of this? It's a check, right? Another one? Okay, let's get rid of that. And I'm going to cover this up. And bring this up here. Okay, so here's another one. So I have two different functions. A square root function and a constant function. So I'm going to graph my square root function. That's a shift to the right 2. And my constant function is a shift up 1. Where do they meet? Right here, where x equals, what does x equal there? X equals 3. Let's see if we're right. The square root of x minus 2 equals 1. I want to undo a square root, so I'm going to square it. When I square that, I get x minus 2 equals 1. X equals, when I add 2 to both sides, x equals 3. And they check. How are we doing? Pretty easy, right? Pretty straightforward. We're just graphing. The only new information is how to solve a square root function. How do we solve a square root function? We square it. How do you solve a cubed root function? Cube it. Good. How do we solve a fifth root function? You fifth it, right? Okay, let's see. Let's get something harder. How about that? Okay, here is what you want to do. You want to make the graph as simple as possible before you graph it. All right? What do you notice about that 8? It's actually a 2 cubed, right? And doesn't a cube and a cube root cancel each other out? So this could actually be written as 2 cubed x. Are you with me? Is that true? 2 cubed? Don't cubes cancel each other out, a cube and a cube root? So this is actually 2 cubed root x equals 4. Now, here's the trick. I could graph that now, correct? I could graph this side, and I could graph this side. But why not simplify it before I graph it? Why not? Yeah, why not divide both sides by 2 first? So I'm going to divide both sides by 2, and I get, let's do this. Now I have the cubed root function of x equals 2. That's easier to graph. You're more than, it's possible to graph it from here. You can even graph it from here if you want to with a table of values. But why not do it when it's as simple as possible? So now I've got f of x. Let me get rid of all this. So now I've got f of x equals the cubed root of x, and g of x is equal to 2. I'll go ahead and graph my constant function, and then my cubed root function it's just the parent graph. So my magic numbers are 1, 1, and 8, 2, and negative 8, negative 2. So my solution is x equals 8. Let me go ahead and do that. Oh, I could have done that here. Let's put them here. G of x is cubed root of x, and h of x is 2. Now I'm going to solve it algebraically. How do I get rid of a cube root? Cube it. So x equals 8. And I have the same thing. Harder one? Sure. Let's see. What should I do that before I graph it? Add 3 to both sides. Make it easier, right? Would it still work if I graphed it that way? Sure, it's going to work. It's just going to look different. You want me to do this one? How about we do that one? Yeah? Anything harder? How about that one?
Let's do that.
That's the hardest one on the front side of your worksheet. Let's do this one. Okay. What's my strategy? What would you do first? Subtract 1 to both sides. Okay. So I have a negative 9x plus 18 equals negative 6. Then what would you do? Can't move 18. I would divide by a negative 1. Get rid of that negative, right? So now I have 9x plus 18 equals 6. Now what would you do? Divide by 3, but you're skipping steps. How'd you get 3? These two have a common factor of 9. Some of you can do this in your head, which is x plus 2, right? The square root of 9 is 3, right? So can't I pull a 3 out? That's really 3 squared. So now I have 3, x plus 2 equals 6, which is really much easier, correct? So now I have square root of x plus 2 and 2. Here's 2. Here's square root of x plus 2 is to the left 2. 1, 1, 1, 2, 3, 4, up 2. So x must be we could start from the beginning if we wanted to. Let me do this. They cut it off. All right, now, I could have started from the very beginning to do this algebraically. But in order to do it algebraically, you have to have only a square root on one side. You can't. If I were to square both sides right now, what I'm really telling myself is this. You guys see that? Doesn't that look like a pain to do? Doesn't look like fun. So simplify it. Before you square both sides, I just got rid of that 5. Before I square both sides, get rid of that 1. Put it on the other side. So now I have, correct? Now is it easy to square both sides? You don't have to. You don't have to take the negative out, because watch this. Negative 1 squared is just 1. Square root squared is just 9x plus 18, and negative 6 squared is 36. Subtract 18 from both sides and you get 18. Divide by 9, you get 2. Isn't that what I got? X equals 2. Okay, that's the hardest one on the front side. I'll leave this up here and give you the worksheet. Yes, sit up. Yeah. That's because it's cubed. Square root, cube root. All right, on the back side, I would say that that's probably the one that's going to look the hardest to you. But before you cube both sides, what should you do? Right now, if I do this, it's cubing this by this by this. It's so easy, you're gonna. I know. I'm just making you think. Can't I just move it to the other side and it becomes positive?
Oh, right.
Now you just cube both sides.
Move it to the other side.
Right? Does that make sense? What about something like this? How would you simplify it first?
Subtract 3.
Subtract 3. Now what?
Divide by 2.
Divide by 2. Now what? What's this? It's the square root. This is the same as this. Right? Remember we learned that on Friday? So couldn't I just... Hold on, Sebastian. Couldn't I just... It's 4. Thank you. Better? Isn't 1/2 to the 2 1? Because 2 minus 3 is 4. Divide by 2 is 2. That's because you're not paying attention, Matthew. So now I have x equals 4. All right. It's like math. All right, well, let's get started.